When SpaceX launched Starship version 3 on May 22, 2026, Flight 12 from the brand new Pad 2 at Starbase, it wasn't just another test. This was the version that finally turns the long-promised heavy-lift dream into engineering reality. The fully stacked vehicle stands 124 meters tall with a 9-meter diameter, a hair taller than previous blocks, but packing dramatically more performance thanks to targeted stretches in both stages. The Super Heavy booster grew to about 81 meters, carrying roughly 4,050 tons of liquid methane and oxygen propellant, up over 400 tons from V2. The Starship upper stage stretched to around 61 meters with about 1,600 tons of propellant. That extra fuel, combined with a lighter overall dry mass, directly feeds into payload capacity. At liftoff, 33 Raptor 3 engines on the booster deliver more than 9,500 tons of thrust. Some reports put it near 10,000 tons force. Each Raptor 3 produces about 280 metric tons force at sea level, roughly 22% more than the Raptor 2's 230 tons force. These engines are lighter at 1,525 kilograms each, with most plumbing and heat shielding integrated internally for simplicity and reliability. Higher chamber pressures, around 350 bar, squeeze more performance from every kilogram of propellant. The result? Starship V3 targets over 100 metric tons to low Earth orbit in a fully reusable configuration, more than double or even triple V2's demonstrated numbers, around 35 tons, and vastly more than Falcon 9's roughly 23 tons reusable, or Falcon Heavy's 64 tons expendable. Early concepts talked about 100 to 150 tons reusable. V3 is the hardware iteration that makes that and potentially higher mature figures achievable without throwing the vehicle away. In expendable mode, some analyses point toward 150 to 200 plus tons, though SpaceX emphasizes the reusable figure for operational economics. The upgrades go far beyond raw size and thrust. V3 introduces an improved integrated hot staging ring on the booster, larger and repositioned grid fins, 3 instead of 4 in some configs, and enhanced reaction control systems. The upper stage gained docking ports specifically for orbital propellant transfer, critical for deep space missions. The PEZ dispenser-style payload door was upgraded for faster, more reliable satellite deployment, enabling up to 60 of the larger next-generation Starlink V3 satellites per flight. That Starlink angle is huge. A single V3 launch can deliver roughly 24 times more bandwidth than a Falcon 9 carrying older V2 satellites. Dedicated Starlink missions on Starship are expected to ramp up significantly from mid-2027 onward, accelerating the constellation toward global high-speed coverage and supporting massive AI-driven data demands. For NASA's Artemis program, this capacity changes the game. The Human Landing System Starship variant can now be refueled in orbit by multiple tanker flights, delivering heavy cargo or crewed landers to the lunar surface. One launch architecture that once seemed marginal becomes routine. The same refueling capability opens serious Mars logistics, propellant depots, heavy habitats, and eventually crewed missions with meaningful payload margins. Think about what 100 plus tons reusable actually means in practice. That's enough for entire space station modules, giant space telescopes, or heavy national security payloads in a single flight. Things that previously required multiple launches or dedicated vehicles. It dwarfs historical benchmarks like the Saturn V's expendable performance, while being fully reusable and far cheaper per kilogram over time. The rocket equation rewards these changes mercilessly. More propellant, better engine efficiency, lower structural mass for recovery systems, and margin for boost back and landing burns. V3 doesn't just add payload. It buys back the reusability tax that limited earlier versions. The first V3 flight demonstrated many of these systems in action, successfully deploying 20 Starlink simulators, plus 2 camera-equipped satellites to inspect the heat shield, even with minor engine anomalies that the vehicle handled gracefully. The consequence is profound. Lower launch costs and higher cadence unlock entirely new markets. Rapid constellation replenishment, in-space manufacturing, lunar industry, and eventually point-to-point Earth transport or Mars colonization infrastructure. What used to require a fleet of rockets now fits on one reusable giant that lands itself with mechanical precision via tower catch. Starship V3 isn't the end. future blocks will push even higher. But it's the version where the 100 tons promise stops being aspirational and becomes operational reality through relentless iteration on engines, tanks, staging, and recovery.
If you want more stories like this every week, like the video and subscribe. Drop in the comments what surprised you the most.